Hello everyone! Thank you for joining me today for a brief introduction on capacitors, where we will cover the basics of this electronic component. Now, first of all, what is a capacitor? Well, a capacitor, as said before, is an electronic component which are applied in all kinds of circuits for multiple purposes. The components come in all shapes and sizes, but should most of the time consist of two electronic conductor plates which are separated by a dielectric. Now, I'm sure the smart you already knows this, but just to go over it again, a dielectric is an insulator which can store energy by becoming polarized. It can range to glass, ceramic, plastic film, air, vacuum, paper, mica, oxide layer, etc. For different functions, a capacitor is able to work in circuits of AC and DC. However, today we are just going to cover DC, direct current. In a DC circuit, the current is actually unable to be carried through the whole circuit and is actually blocked by the dielectric of the capacitor, so it stops at the conductive plates of the capacitor. Now, let's look at the electron flow of the circuit for a clearer view. The electron flow travels the opposite way around the circuit in contrast with the current. So it starts at the negative terminal of the power supply, and if in a normal circuit, it should be able to travel around the circuit, finally reaching the positive terminal. But in this situation, the electron flow reaches the conductor plate of the capacitor, gets stopped by the dielectric, and the electrons become spread out amongst the plate, making the charge on the plate negative. Due to the concentrated negative charge on the negative plate, it is able to interact with the electrons in the other plate through the dielectric by electric force. As similar charges repel, the electrons on the negative plate is able to force the electrons on the other plate to move away until it is given off from the plate and travels through the circuit back to the power supply, thus losing the electrons, turning the other plate into a positive plate. As time goes on in the DC circuit, the potential difference and charge between the two plates become larger and larger till it reaches its maximum capacitance. If we had a voltmeter and ammeter in the circuit set like this, the graph would look like this. Capacitance, in simple words, is the amount of charge an object is able to store. There is a formula for capacitance, which is C equals Q over V, where C is capacitance in farad, Q is charge in coulombs, and V is voltage in volts. After the capacitor is fully charged, it can be linked to another circuit to be discharged, such as this one I drew here. The capacitor, after being fully charged, can act as a power supply, where a flow of electrons are released from the negative plate towards the positive plate. This flow of electron causes a current in the circuit and energy to the components in the discharge circuit. The time which a capacitor discharges also varies, depending on the capacitance and the resistance in the circuit, given by this equation, Q equals Q naught times E to the power of minus T over RC, where Q naught is initial charge, Q is current charge during the discharging, T is the time since discharging starts, R is the resistance in the circuit, and C is the capacitance. There is also a formula for voltage, which is similar to this formula, which is V equals V naught times E to the power of minus T over RC. As in terms of application into engineering and why it is important, the usage of capacitors in circuit is absolutely crucial, and although I've only explained a very simple function, there are a wide variety of uses in circuits for the capacitor and commonly used even in common electronic products, which makes it a very important component to understand. That is the end of this introduction. Thank you for watching. Bye bye.